Okay, so we started with probability in the last class. We started with the types of events, the tiny definitions, outcomes, and everything. Um, then we started with the different types of events, algebra of events. We also went through algebra theorem, addition theorem. Um, we just started with the conditional probability. Okay, so we're going to continue with the same. Conditional probability mein I basically taught you how to do the sums on conditional probability without formulas. Okay, last time the formula was given to you, but then I also taught you in the beginning without formulas how will you do, and then afterwards I said we'll do it using formulas. So we're going to continue with that same thing now. Now suppose what was conditional probability, by the way? Let us just quickly a quick recap of conditional probability. Conditional probability was nothing but, I'll just write it in short. All right, I'll just write it in short because the explanation and everything was done last time. Something if you have two events, say A and B, okay, sample space S you have, and you have two events A and B associated with the sample space, and then the probability of occurrence of event A under the condition that B has already occurred. Okay, probability of occurrence of A under the condition that B has already occurred, and also probability of B is not equal to 0 is called as conditional probability. Okay, so this is something probability of occurrence, and such that under the given condition as this is given to be true or this has already happened, B has already happened, right? And probability of B should not be equal to 0. So last time we solved a few sums on cards, I guess, without the formula, but I'll also tell you the formula. What is the formula? Probability of conditional probability formula is A intersection B upon probability of B. Okay, that is why the definition may probability of B should not be equal to 0. Otherwise, if this is equal to 0, then it will be wrong, correct? So then we have probability of A intersection B upon probability of B. As I said, it is not always a hard and fast rule that it has to be written as probability of A such that B only. It can be written as ulta also. I told this to you last time as well. But this will be read as probability of occurrence of event B under the condition that A has already occurred. Alright, so that will be the condition. That is how it will be written. So इसका formula कैसा रहेगा? Probability of B intersection A intersection and B and B intersection A. The numerator will not change. It is of course the same thing. Upon denominator will be probability of A. This time probability of A should not be equal to 0. Okay. Okay. So last time we had solved a few sums. We'll continue. Find the probability that a single toss of a die will result into a number less than 4. Okay, less than 4 if it is given that the toss resulted in an odd number. Okay, if the toss resulted in an odd number. All right. So, पहली बात तो we have to write it correct. As I said, now you have to find a probability of occurrence of one thing such that another given thing, which is true. So Abhi either basically telling you about two lines, two major statements. Probability that a single toss of a die will result a number less than 4 if it is given that the toss resulted into an odd number. Okay, so you have to, as I said last time, you can write it anyhow. A such that B you can write, B such that A B you can write, whichever way you want. So अभी यहाँ पे basically talking about two events, correct? हमारे पास two events है, एक तो less than 4 है और एक odd number है. Alright, so we can write let event A be such that the number toss resulted into an odd number. Alright, resulted into an odd number. The next one, as I said, we have two events. So let event B be such that number is less than 4. All right, less than 4. Now, when you read the statement of the question properly, they're telling you that number result in an odd number if it is given that the toss resulted in an odd number. Okay, so this is something which is already given to be true, right? That it is an odd number. So how do we write this in that form? Conditional probability form. It will be P of this one or this one, A such that B or B such that A. Of course, it will be probability of B such that A, no? Because here B is something, probability of occurrence of, this is something you have to find, probability of occurrence of a number when this thing is tossed, the number should be less than 4. Under the given condition that it is an odd number. So यहाँ पे A जो हमारा event है उसको हमने लिया है as odd number. So this is something we have to find. What is the formula? As I said, the formula is nothing but A intersection B upon probability of A, right? Okay, so we will have to find everything. By the way, we said let A be an event that it results into an odd number, correct? So this is of when a die is rolled, correct? So what is the chances that it is an odd number? These are the odd numbers: 1, 3, and 5. Sample space we know it is 1, 2, 3, 4, 5, 6, correct? So therefore, what will be probability of A? Probability of A will be nothing but number of elements of A upon number of elements in the sample space, correct? Which is equal to, what is number of elements in the event A? 1, 2, 3. 3 upon, what is the number of elements in the sample space? As I said, 1, 2, 3, 4, 5, 6. So that is 6, which is equal to half. Okay, half. Now the next one, B. Coming to the next event, what was the event B? The number should be less than 4, correct? So how many numbers are there which are less than 4? 1, 2, and 3. Less than 4 they're telling you. So 4 will not be included. If they tell you less than or equal to 4, that time 4 will be included. Okay. So therefore, probability of B, which is equal to 1, 2, 3. Okay. So what is probability of B? So that will be equal to, you can find out if you want, or even if you don't find out, it is okay. But let me just tell you why am I doing it just now. This is again equal to half. All right. Now, what is actually required in the question? The formula, they need probability of A intersection B upon probability of A, correct? So probability, what will be in A intersection B? Now, what will be in A intersection B? A intersection B are those numbers which are present in both A and B. So which are those numbers which are present both in A and B? 1, 2 is not there, 3, right? So 1 and 3. So what is there in A intersection B? 1 and 3. What is number of elements in A intersection B? That is equal to 2. Okay. Okay. So now what will be probability of A intersection B? This is what we want, correct? This is the major formula that we have. So this is what we want. So probability of A intersection B will be equal to n of A intersection B upon n of S. That is nothing but n of A intersection B means number of elements in the intersection. How many are there? 2 upon number of elements in the sample space. So that is equal to 1 by 3. Alright. So now we have got almost everything. Yes, almost everything. Yeah, we have got everything. So this was the formula that I'll just rewrite it again. Initially, I wanted you to know कि what formula we have to use. मतलब how it is to be written. A लिखना है या B such that A लिखना है. Now we have got all the values. So this is nothing but 1 by 3. Probability of A, how much was that? Probability of A is half. Okay. Is equal to half. Alright. Now on calculating this, that 2 goes super, so it will become 2 by 3. Okay. So the probability of the number less than 4, given that it is odd, is 2 by 3. Now if you see, just one notice, because I was just doing it in the flow, I didn't tell you. The formula probability of A intersection B upon probability of A. A मतलब ये जो second alphabet लिखा है इसी का probability चाहिए. Nowhere are we using probability of B. So even if you don't find this, it is absolutely fine. Just here I have found out. See, probability of B, which is equal to 3 by 6, which is equal to half. Why should we find out when we don't need it? So that's not a compulsory step. Okay, so just we were doing it in the flow, so we have written. But otherwise you know, जैसे अब मैंने event A को odd number लिया है और event B को less than 4 लिया है. but there is no rule, right, कि इसी को odd number लेने का है, इसी को less than 4 लेने का है. That's your choice. So if you do it उल्टा, मतलब अगर तुम B को लेते हो as odd number and A event को लेते हो that it is less than 4, so then it will be entirely ulta, A such that B. Okay, so then the formula will also change. That time you will not need probability of A, but instead you will need probability of B. All right, so you just have to be careful. I mean, it comes with time. Slowly when you do a little more problems. Yes, probability of A complement. Now this is not a what do you call, not a word problem. This is like quite simple. इसके लिए you only need to know for the theorems, okay, the statements, something like that. If probability of A complement is equal to 0.7, probability of B is also equal to 7. Probability of occurrence of B such that A has already occurred, this is conditional probability which we just did, is equal to 0.5. We have to find out probability of A under the event that B has already occurred and probability of A union B. Okay. Okay. So पहले part तो we will focus on the given things and also the things that we have to find out. Okay. पहले तो they are saying that ये find करना है. ठीक है. अभी we just dealt with the conditional probability in the above sum. So let us do this A such that B has already occurred. What should be the formula? We just now we did A intersection B upon ये second वाले का probability, correct? Upon probability of B. Okay. Now these two things, how what all do we need? We need A intersection B ka probability. Is it given? No, this is not given. Is this given? Probability of B? Oh yes, this is given. So we just have to find out this one thing, probability of A intersection B. How will we find out probability of A intersection B? Unlike the previous problem, event A tha, event B diya tha. So we wrote the elements, like we listed out all the elements in A intersection B. Then uska probability we found out. But right now we don't have. But to find out this value, probability of A intersection B, extra information is given to us, right? This extra information is given to us. Just a second, I'll erase it. Number. Yes. Yes, that is probability of B such that A that is given to us. So how will we find out this using इसका help? इसका formula क्या है? Probability of B such that A का यही है ना formula. Probability of B intersection A और A intersection B दोनों का मतलब एक ही होता है upon probability of A, right? इसका मतलब क्या है? ये वाला value तुम्हारे पास है, right? This left hand side, this value you have. This value we have to find out, as I said, and this value also we need because see A nahi hai probability of A, probability of A complement hai, but we can find out no A, so this value also we can easily find out with the help of these two. We can easily find out this one, that is nothing but probability of A intersection B, and when you find out this one, we can easily find out this one. Are you understanding? So it's important, all the formulas are related to each other, so it's important that you understand all the formulas and then it will be easy. So now our first aim is to find out this probability of A क्योंकि उसका complement दिया है, हाँ हमको पता है कि complement से उसका probability कैसे find करते हैं. Since probability of A complement is equal to 0.7, what will be probability of A? Probability of A is 1 minus probability of A complement, that is equal to 1 minus 0.7, that is equal to 0.3. Okay, so that's your probability of A. All right, probability of A is 0.3. Now we have got this value. Okay, we have this value also. We can find out this value now. I'm just writing the formula, which is equal to probability of A intersection B. As I said, A intersection B और B intersection A दोनों सेम ही होता है, तो तुम उसको उल्टा भी लिख सकते हो. I mean, B intersection A लिखो, B पहले लिखो या A बाद में लिखो. Both are exactly the same thing. Okay. Now, which is equal to this value. B such that A is equal to 0.5. Probability of A intersection B. This is something we have to find out. Upon probability of A is 0.3. So what will be probability of A intersection B? That is equal to 0.5 into 0.3. Okay. 5 3s are 15 and then दो decimals के आगे 0. So that will be 0.15. Alright. So probability of A intersection B is 0.15. Now, why did we find out A intersection B? Because we actually wanted to find A such that B. उसके लिए हमको probability of A intersection B चाहिए था. So we will write that. Now what we need, probability of A. This is what we wanted to find, and this was the formula, which is equal to 0.15 divided by probability of B is how much? 0.7. 0.7. Now I got to divide this. Okay, so when you divide it, you will get the answer as 3 by 14. Remove the decimals. Multiply. You can, what you can do is multiply 4 by 100 kar lo, 15 by 70 रहेगा, and then you have to cancel and then write the lowest form. The lowest form will be 3 by 14. Okay. Yeah. So A such that B is also we have found out. This value also we have found out. Now the only thing remains is probability of A union B, correct? A union B ke liye, how can we find out A union B? If you remember, mm, last time we did something called as addition theorem. Okay, addition theorem means in case if suppose S is the sample space, A and B are two events. Okay, and then occurrence of at least one of the events was your addition theorem, when probability of at least one, that is A and B may say, can always be written as, this was the formula, probability of A plus probability of B minus probability of A intersection B. Alright, so this is the formula. This was your addition theorem. Now with the help of this, we can easily find out probability of A union B. So let us write down, by addition theorem, probability of A union B will be equal to probability of A plus probability of B minus probability of A intersection B, which is equal to all the values now we have. Probability of A was equal to how much? A is 0.3, B is 0.7, A intersection B is 0.15. Yes, so we'll write all the values. A is 0.3, B is 0.7, A intersection B is 0.15, 0.85. Okay, yes, that's the final answer of probability of A union B. Okay, so we have to go through all the formulas and then you can easily you'll be able to tackle. Now coming to the next theorem, addition theorem, conditional probability. After all of that, you have something called as, when you had addition theorem. Now the next thing is the multiplication theorem. Okay, so multiplication theorem ka statement is given. Let S be a sample space associated with the given random experiment. Let A and B be any two events defined on the sample space. Then the probability of occurrence of both the events is denoted by A intersection B is given as this formula, alright? Probability of A intersection B, which is equal to probability of A into probability of occurrence of B, given that A has already occurred. Okay. Now, what was the difference? What's the difference in addition and multiplication theorem? Addition theorem, what did they tell you? Probability of occurrence of addition में they said at least, right? At least one of the events, A or B में से. यहाँ पे multiplication में they're telling you occurrence of both the events. Okay, so multiplication में it is both the events. Okay, both मतलब A भी और B भी, मतलब A and B both. So and is always, as I told you, it's intersection, right? So and is intersection, and the formula is given like this. So formula of A intersection B, which is equal to, there are two formulas. If you're writing it with respect to probability of A, so it will be like this. You don't have the proof, you only have to remember the formula. But if you're writing it with respect to B, it will be probability of A such that B. Alright? Okay. So that's it. So this was the statement and the formula you have to remember. Please remember, यहाँ से if you're starting with A, then the next one will be B and last में you will have A. If you're starting with B, उसका बाद वाला will be A and then उसका last में will be B. That's how, मतलब alphabets will not come close. I mean, बाजू बाजू में it will not come. Okay, that one thing you have to remember. Now let us go to the word problems. Just a second. Okay, I missed out a. Okay, suppose if you have a question like this, okay, two cards are drawn from a pack of 52 playing cards, one after other without replacement. What is the probability that both cards are ace cards? Okay, two cards are drawn from a pack of 52 cards, one after other, without replacement. Okay, what is the probability that both cards are ace cards? I suppose you all know what is that ace cards. A जिसमें लिखा रहता है that ace cards is the A वाला card. Okay, so अभी इधर the 52 cards है, two cards are drawn one after the other without replacement. Okay, without replacement मतलब replacement नहीं हुआ है कुछ भी. Replacing means what? वही same इस पे वापस से प्लेस होना. मतलब there are 52 cards, you're removing one card, correct? One card when you remove, suppose 52 cards है, one card you're removing, two cards you have to actually remove. So one card after you remove, how many remaining cards are now? 51 only, correct? Now वो 51 में से you will pick up that second card. That is without replacement. मतलब पहला 52 है, हमने एक कार्ड निकाला, कुछ तो था, फिर उसको वापस रख दिया और फिर सेकंड कार्ड क्लिक किया, ऐसा नहीं है. ऑलराइट, पहले 52 था, उसमें से यू पिक्ड अप वन, नाउ देयर आर 51, उसमें से यू पिक अप द सेकंड. दैट इज व्हाट इट मींस विदाउट रिप्लेसमेंट. विद रिप्लेसमेंट अगर ऐसा कुछ होता है, मतलब हम पहले 52 में से एक निकालते हैं, देन वो जो एक निकाला है उसको you put it back. So now again there are 52 only. Now 52 में से you pick up the second card. That is what it means with replacement and without replacement. Okay. Now, just a second. So you have to do it without replacement. All right. So we're doing this thing. As they're telling you, there are two cards are drawn. Initially there were 52 और फिर बाद में second card was drawn, तभी there was no replacement. Okay, so बाद में there are only 51 cards. Okay, so now of course as I said, how many number of red cards are there, how many number of queen, king, jack, black कितने हैं, club cards कितने हैं, all suits कितने हैं, वो सब तुमको पता होना चाहिए. I don't think we have done an ace card वाला problem till now. So let us do it. As they're telling you, there are two cards that are to be drawn. Okay, two cards means I can name them as two events. Okay, let A be an event where the first card drawn is an ace card. All right. Let B be an event that the second card drawn is an ace card. Okay. First card drawn is an ace card. Second card drawn is an ace, ace card. That will be your second event. I'm just naming the number of card जो pick किया है उसको as separate events. Okay. What is that probability? Now, what do you want to find? By the way, what is the probability that both cards are ace cards? मतलब दोनों, पहला वाला भी ace है and second वाला भी. Both means A and B both. As I said, both is nothing but that comes under multiplication theorem. Okay, where is that word? Both the events are occurring right at the same time, so that is nothing but multiplication theorem, and it is denoted using probability of A intersection B. So here again we are going to find out probability of both are ace cards. Correct, both are ace cards. How do we denote it in terms of probability of events? Probability of A intersection B. All right. अभी इसका फॉर्मूला तो अभी थोड़ा टाइम पहले ओनली वी डिड. वी हैव टू फॉर्मूलाज, करेक्ट, प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी का. either you pick up the first one or you pick up the second one, both are okay. Okay, so timing, let me pick up the first one, probability of A into probability of occurrence of B such that A has already occurred. So let me write it that way. probability of A into probability of occurrence of B, such that conditional probability, that is the same. All right. So now after this, what would we have? This is nothing but, now what is probability of A? हमको ये दोनों value find करना है. To find out probability of A intersection B, we need to find out two things. What is this? Probability of A. Probability of A. What will be probability of A? By the way, what was event A? Event A was first card drawn is an ace card. Okay. फर्स्ट कार्ड ड्रॉन इज एन एस कार्ड. सो पहले हम इसका नॉर्मल प्रोबेबिलिटी कैसे देखते हैं? पहली बात तो कितना एस कार्ड्स होता है, राइट? सो देर आर इन टोटल 4 एस कार्ड्स. यू हैव टू रिमेम्बर दिस. जैसा 4 जैक है, 4 किंग है, 4 क्वीन होता है, वैसा 4 एस कार्ड्स होता है. ओके, सो 4 एस कार्ड्स we are going to pick up from how many total number of cards? From total 52 cards. These types of probability we have already done. How the answer is 4 by 52, and on reducing this you get 1 by 13. Now if you still have a problem with how did we get this 4 by 52, you can go through the previous videos. This is actually on combination, जिसे हम बोलते हैं कि हमने red card, probability of red cards picked up. Okay, so पहले we write n of s, then in case if we have to pick up 2 cards, that will be done in 52 c2 ways. Then red cards है event A, तो 26 red cards है, उसमें से how many you have to pick up? 26 c2. Right? So abhi they are only picking up one card, no, initially. So out of 4, one card is picked up in 4c1 ways, and denominator when the sample space was 52c1. So this is nothing but 4 by 52. That is how this has come. Okay. As I said, I mean, everything is a continued video. You have to go through everything. Only then you will understand. If you skip, then it will be a problem. So iska detailed explanation of 4 by 52 ka everything we have covered in the previous sum. Actually, the previous lesson. Permutation combination of it. So this is 1 by 30. Now we have found out value of this probability of A. We have to find out probability of B such that A has already occurred. Now they have told you clearly because of the word without replacement. एक event has already happened. मतलब जो पहला वाला ace card था उसको हम वापस replace नहीं कर रहे हैं, correct? तो अभी remaining how many cards are there? 51 only, as I said. Since first ace card, their first ace card which had picked up is not replaced, because he had said, it clearly strictly mentioned, it is without replacement, replaced in the back. Therefore now we have only 51 cards, right? 51 cards only we have. और ये 51 में टोटल हमारे पास कितने एस कार्ड्स थे? देयर वर 4 एस कार्ड्स, करेक्ट? 4 एस कार्ड्स में फर्स्ट इस चांस में एक एस कार्ड हमने ऑलरेडी कलेक्ट कर लिया है, तो इसमें कितना बचा रहेगा? विथ ओनली 3 एस कार्ड्स. ओके, 51 टोटल कार्ड्स, उसमें से 3 ace cards are possible. All right. So now what is the probability of getting the second ace card? That is what we have to find. That is what probability of B such that A has already occurred. Are you understanding the difference now? B such that A has already occurred. What was A? A is first card taken is already a ace card. Now what is the probability that the second card will also be an ace card? इसका मतलब यही होता है. Okay, so we are going to find out this one such that A, which is equal to, now how did I tell you how are you going to do this? This is again same. इसका sample space कितना होता है? अभी we only have 51, correct? 51 में से how many they're talking about ace cards now. So that will be 3 by 51, like how we wrote यहाँ पे. Initially the total number of cards 52, और उसमें से ace cards कितने हो सकते हैं? Probably 4, right? So because 4c1, so that उसका explanation also I had written over here. So that is 4 by 52. And here we have one less, no? भले एक ही कार्ड कम हुआ है. कौन सा वाला कम हुआ है? एस कार्ड कम हुआ है. सो टोटल नंबर ऑफ कार्ड्स कितना है? अभी 51 है, पहले 52 था. अभी टोटल नंबर ऑफ एस कार्ड्स कितना है? पहले 4 था और अभी 3 है. सो दैट इज हाउ इट इज 3 by 51, and when you reduce it we get it as 1 by 70. So now done, job done. So probability of both are ace cards, which is equal to probability of A intersection B is nothing but probability of A into probability of B under this condition. That so answer will be 1 by 13 into 1 by 70. So you're just going to multiply. So that will be 1 by 13 into 1 by 17, and the final answer is 1 by 221. So that's how the final answer goes. So this is an example of addition multiplication theorem. Multiplication where they talk about both the events occurring. Yes, this as well as that first event B as well as the second event B, or any number of events for that matter. Right? Is that there over here? No, we'll do that a little later. Okay, a number of events for that matter. So the final answer is 1 by 221. So you have to read the question properly. Abhi, because we are doing that statement and then uska related sums immediately back to back. So then you might not have a problem. But in the exam, you will just be given one question like this. ऐसा ही एक question दिया रहेगा. Or that time you should read the question and then you have to only understand कि इसमें क्या आएगा. Addition आएगा या multiplication theorem आएगा. What kind of theorem will come in this. Okay. So that is something, it's your decision you should make and you should attend the question. Okay. And next one also, let us do this one. An urn contains 4 black and 6 white balls. Urn is nothing but like say a very big container. Okay, contains 4 black and 6 white balls. 2 balls are drawn one after the other without replacement. Okay, without replacement. What is the probability that both balls are black? The second ball is black. Okay, abhi there are two criterions coming. ऊपर वाला question was straightforward कि both are race cards, so we were done. अभी यहाँ पे they're telling you first is okay, both are black, both balls are black. The second ball is black. Okay, so let us do it for both. Okay, we'll do it. Suppose we'll start it in the similar way like how we did it for the upper wala sum. Let A be an event. Let event A. First ball drawn is black. Okay. First ball drawn is black. What will be event B? Event B is second ball drawn is black. Well, जैसे वहां पे किया था, we're going to follow the same steps. Now the required this thing. Both are black balls. This is exactly similar. I'm just following. So both probability that both are black balls. This is probability of A intersection B. This is the formula as I said that we had used last time. I'm just using the same formula. Now what did we do? We found out both the things, correct? दोनों find कर रहे थे हम, probability of A भी और B भी. What will be probability of A now? A means, what are they talking about? What is A? First ball is black. Okay, probability of the ball being black. So you will be writing total number of balls upon black balls. Total number of balls are how much? 4 black plus 6 white. So that's your sample space. 4 black plus total number of 10 balls. And they're talking about A event is about all black. So 4 by 10. Okay, so 4 by 10. I can write it as 2 by 5. That's okay. And the next one, probability of B such that A has already occurred. Now, what do you think can this answer be? Abhi, now when you have already done that sum, you should know that shortcut. When you're doing that, both the balls are black and both are white या both are ace में, you should know that shortcut. अभी जैसे यहाँ पे क्या था 4 by 52 था. You only have to find out probability of A. B such that A will be exactly similar, one number less. 4 से 1 कम तो 3, 52 से 1 कम, that will be 51. Remember, this will not possible all the time. This is only possible when that word without replacement is given. जैसे अभी यहाँ पे दिया है, ये वाले सम में भी, balls वाले सम में भी दिया है without replacement. So here 4 by 52, जो probability of A was 4 by 52, that became 3 by 52, right? Probability of B such that A become 3 by 51. एक एक कम हो जाता है. So यहाँ पे भी what will it be? Again, when you're not replacing that black ball what you have got, so now the total number of balls will be 9 and all total number of black balls, probability of black balls will be 3 by 9. Okay, so now probability of both black balls will be equal to probability of A into probability of B such that A, which is equal to 4 by 10 into 3 by 9 upon okay, we can write this, this gets cancelled, no? 3 ones are 3 threes are 2 twos are 4, 2 fives are. So this is 2 by 15. Okay, so probability that both our black balls are or A intersection B, which is equal to 2 by 15. All right, so that's the probability. Yes. So the next one. Now the next one is the second ball is black. Okay, the condition that they're telling you that the second ball is black. See, there are two balls that are being drawn, one after the other, without replacement. पहला जो आ गया है वो आ गया है और जो वो पहले जो तुमने choose किया that you're not putting back into the container, then you just have to see that the second ball has to be black. What is the probability or what are the chance? Okay, but are they telling you anything about the first ball? They're not telling you anything about the first ball, right? They're not telling you anything about the color of the first ball. They just said that the second ball is black. They're not telling you anything about the first ball. So we have two cases. First ball picked up can be black or white. Let me see if we have space. Yes. Okay. The first ball can be black or white, right? This is just because you're focusing only on the second ball, right? They're not telling us anything about the first ball. So the first ball can either be black or it can be white as well. So we are going to deal with two conditions. We'll do it one by one simultaneously. Suppose we'll take it as case number one and case number two. Suppose case number one, the first ball is white. Okay. Suppose it is white. Okay. So the probability that the second ball is black. What do you have to find? What are we going to find? We just have to find that the second ball is black. ऐसा कितना chances है? तो ये जो second ball जो black है वो बोल रहे हैं the first ball कुछ भी हो सकता है, black हो सकता है या white हो सकता है. Please don't forget हमको probability that the second ball is black वो वाला probability find करना है. तो first ball अगर white है तो what is the probability that second ball is black? Okay, so how will you find this out? Second ball is black means this is suppose if you're telling this is suppose your probability of B, correct? Your second ball is black, all right? When the first ball is white, okay? So how will you do this one? Yes, please remember they're telling you first ball is white, पहला ball white है, second ball sorry, first ball white है, second ball black है, okay? तो पहला वाला जो white ball है वो तुमने कितने बॉल में से चूज किया था? सो दिस इज लाइक फर्स्ट व्हाइट बॉल 10 white balls में से initially there were 10 total number of balls. उसमें से how many white balls you had? We had 6 white balls. So the probability that it is first is white ball is 6 by 10. Okay, and the second is black ball. So now see, there were 10 balls and उसमें से 6 white and 4 black were there. So 10 में से 1 white is already picked up. Now how many total number of balls remaining? 9 balls, correct? In total are remaining. And what is the probability that the second ball is black? Now see, initially picked one was white. So you need not reduce this number to 5. Are you understanding? Previous problem you had both black or both ace cards, something like that. Only then you will minus, ये दोनों minus करोगे ना, one से एक एक minus करोगे. But यहाँ पे first ball white था, second ball will be black. So अभी ये 9 में से total कितना black balls है? Of course 4 है. Because पहले कोई भी black balls को नहीं निकाला था, right? So this will be 6 by 10 into 4 by 9. The final answer is 4 by 15. Now, if you've understood this, then I think the second case is very, very easy. What will be our second case? When the first ball is black. The first ball is black. All right. So now you have to find out that the probability that second ball is black. All right. Now this is nothing but we have already done. What is that? First ball is also black, second ball is also black. What does that mean? That means both are black. जो कि हमने ऊपर अभी just किया था. So you can just write it. That is nothing but 4 by 10 into 3 by 9. So you can just write. So that probability will be nothing but 4 by 10 into 3 by 9. This answer is 2 by 15. Okay. All right. Okay. So now just understand this is not the end of the question. Let me just make it clear one more time. one last time. This is not the end of the question. We have to still work a little more on that. Okay. So now they initially started with both balls are black, correct? We had asked us two questions. Dono black hai. Then the second ball is black. Dono black ke liye, I suppose it is understood. It is very similar to the previous sum. जहाँ पे दोनों were ace cards. Now here the second ball is black. All right. Second ball is black means you can either have the first ball as white or you can have the first ball is black. So the second ball has to be black. This is a compulsory condition. Okay. So अभी इस पे से हमने दो केसेस लिखे. फर्स्ट बॉल इज व्हाइट. पहला बॉल व्हाइट है. टोटल कितना बॉल्स है? 10 बॉल्स है. उसमें से कितना व्हाइट है? सो दैट इज 6/10. अभी 10 में से एक व्हाइट निकाल दिया है. So now there are only 9 balls left. But the second ball is black. So total how many black? So that's 4 into 9. Okay. The next condition is first is also black, second is also black. That means both black, which you've already done it above. So the same answer is 2/15. Now, the total probabilities. What did they tell you initially to find out? The second ball is black. But we didn't knew which was the condition. It could have been any one among these two conditions, right? पहला वाला white होके second वाला black हो सकता था, या पहला वाला black होके second वाला भी black हो सकता था. Anything among the first case or the second case is possible, right? So it's either this one or this one. So when it is or, it's always addition, as I've told you. So probability of the first one being white and second one being black, or else probability of first also black and second also black. So when you get the answer, you kind of add up and then you get the answer of 3 2s are 6, 3 5s are 15. So this is the final answer of the second sub question. It seems to be a little confusing, but it is very, very, very easy. You have plenty of sums in the exercise, miscellaneous. You can try those, but it's very, very, very easy. All right. So now the next type of events we can do is the last one, probably. Yes, the last one. That's nothing but independent events. Okay. Independent events. Now, independent events में let S be a sample space associated with the given random experiment. Let A and B be two events defined on the sample space S. Defined on the sample space S. If the occurrence of one event does not affect the occurrence of the other event, then the two events are said to be independent. Okay, what is the name? The name independent only means that they are not dependent on each other, correct? So that is what it means. If you have two events A and B, then the probability of occurrence of one event, okay, does not affect the occurrence of the other event. Okay, so then the two events A and B are said to be independent, and uska formulas as is given. If probability of A and that B, which will be equal to probability of A, such that B dash, okay, will be equal to probability of A, or it is ulta. Then A and B are independent events. Now you have something called as corollary. Corollary means um, how do you call that? By the way, let me just explain this to you one more time and then we can, I guess, go to the corollary. I think I'll do that together, but let us do this. Probability of A plus ZB. What does this mean? Probability of occurrence of A under the condition that B has occurred. What does this mean? Under the condition that B has occurred. So that means it is related. But agar iska ulta, probability of A such that B dash means probability of A such that B has not occurred. No, such that B complement means, how do you read this? The probability of occurrence of A under the condition that B has not occurred. So that is like uska ulta na, upar wale ka. And likewise the second one, when you do it ulta, probability of B such that A, or else probability of occurrence of B under the condition that B has not occurred. So then they are independent events. Ulta ho gaya, alright? Now the corollary, as I said, corollary matlab small जैसे you have a big theorem and then you have a corollary मतलब you are using that above theorem or you're using the fact that the above theorem is true and then you're using it for some small thing that you have to understand. What is the corollary? You can write it in the next line. I should have anyways. If A and B are independent events, Then probability of A intersection B, please understand this formula. A intersection B will always be equal to probability of A into probability of B. Okay, when they are independent, this is the formula for independent events. Okay, when A and B are independent events, probability of A intersection B will be equal to probability of A into probability of B. Okay, then this is only when you have two events, no? But अगर तुम्हारे पास ज़्यादा events है, A, B, C, D, so on and so forth. We have so many events which are independent of each other. It will again, the same rule will apply. Suppose if we have three events, A intersection B intersection C, whose answer will be also probability of A into probability of B into probability of C. Like n number of events. Suppose probability of A1 intersection A2 intersection A3, so on and so forth till intersection AN. It will again be the same thing. Probability of A1 into probability of A2 into probability of A3 into probability of AN. Okay, that's how it goes. Independent events. Hmm? You just have to see what all events are there and a few remarks. Okay, you have to remember. Let us go to some remarks which you may have to use in the kya bolte hain, word problems. If A and B are independent events, then the first thing is A and B dash are also independent events. Okay, if A and B are independent, then A and B dash are also independent. Okay, A and B dash are also independent. Also, if A and B are independent, then A dash and B dash will also be independent. Okay. Also, जब ये है A and B dash, तो उसका उल्टा भी तो true होगा ना? A dash and B will also be independent. Okay, so these are the few remarks you have to remember, which you may need or you may use it in the solving word problems, as I said. Okay. So only when you have A and B are independent events, that time all these things will also follow. Any other events also for that matter. If C and D are independent, C and C complement will be independent. C complement and C will be independent. C complement and D complement will also be independent. Okay. So you have to remember this. Coming to word problems. Okay. Two cards are drawn at random, one after the other. Given that the first card first card drawn is non-face red card, second card is a face card. Okay, check whether events are independent if the cards are drawn uh, without replacement, with replacement. Okay, so you have two criterions. Now you have to kind of remember this. You have to do this problem. अभी इसमें ऐसा नहीं है कि जैसे लास्ट टाइम दे हैड गिवन एड फाइंड करो एटलीस्ट फाइंड करो, ऐसा नहीं है. इधर दे हैड जस्ट गिवन एज अ डेफिनेशन ऑफ इंडिपेंडेंट इवेंट्स और वो पूछ रहे हैं कि ये कंडीशन वी आर गिविंग यू, द सिचुएशन वी आर गिविंग यू, you find out whether it is an independent event or not. Okay, so now how will we do this? Suppose if I name the card, see they're telling us two things. Given that the first card drawn is a नॉन फेस रेड कार्ड है बट वो फेस कार्ड नहीं है. फेस कार्ड जैसे आई टोल्ड यू, फेस कार्ड्स में हाउ मेनी यू हैव 4 जैक, 4 क्वीन, 4 किंग, दीज आर ऑल फेस कार्ड्स. ओके, तो ये जो चार टोटल 12 है, इसमें से 2 किंग, 2 क्वीन, 2 जैक ये रेड में होता है और 2 क्वीन, 2 किंग और 2 जो जैक है ये ब्लैक में होता है. तो ये जो फर्स्ट कार्ड ड्रॉन है, दिस इज अ नॉन फेज रेड कार्ड, मतलब ये सब नहीं है. इट विल बी समथिंग लाइक दिस. ओके, नॉन फेज रेड कार्ड एंड द सेकंड कार्ड is face card. Okay, second card is face card. Face card means 12 total. This we know already. Check whether the events are independent if the cards drawn are with without replacement and with replacement. Okay, let us quickly write it. It seems to be very what do you call, very complicated. Let us write and make it simple. Let event A be first card drawn is a non-face red card. Okay, let B be that second event when the second card drawn is a face card. All right. Okay. So now, let us find out the probability of both the events. What will be probability of A? What will be probability of B? One second. Space. Yes. What will be probability of A? The question is over here. No problem. We won't space. Then we'll write it later. Probability of A. The first card is a non-face red card. All right. So probability of A. Total number of elements in the sample space. That will be 20, or the remaining ones. Remaining non-face red card. पहले बात तो it has to be a red card. Yes. So there are 26 red card. But वो उसमें face नहीं होगा. Face नहीं होना चाहिए. As I said, 2 king, 2 queen, 2 जाके ये red color में रहेगा. और 2 king, 2 queen और 2 जाके ये black color में होता है. Total 6 red cards में होता है. और टोटल 6 ब्लैक फेस कार्ड होता है. टोटल 6 रेड फेस कार्ड्स है. टोटल 6 ब्लैक फेस कार्ड्स है. तो अभी इन्होंने क्या बोला है? रेड है, मतलब वो 26 में से है, बट ये 6 नहीं है. ये जो फेस कार्ड्स है, रेड फेस कार्ड्स, इन 6 है. तो इसमें से यू विल माइनस दो 6 एंड देन यू विल गेट द आंसर एज 20. This is the remaining total number of non-face red cards in the pack of playing cards. So this is nothing but 5 by 13. The next probability is probability of event B, that is second card drawn is a face card. Now this one I have told you already. Now the second one drawn is a face card. Okay, so let us do the probabilities first. The second one drawn is a face card. Face card, total cards is 50. Total face cards are 12, as I just told you. That is 3 by 13. All right. Now the required probability. What was the required probability? That the given card drawn is a non-face card and the second card is a face card. Okay. So required probability is second card drawn is face card given that it is a red card. Correct? Now is ये something हमको find करना है given that the first card is a non-face red card and the second is a face card. Okay. Abhi, whether the events are independent, that's something you have to find, and without replacement and with replacement. Now, because of this two condition, these two criterion, मैं इसको two separate cases लिखूंगी. जैसे ऊपर भी wrote ना, first white and then black, second black and then first black and then second black. So we will write this as two different cases without replacement and with replacement. Let us write it over here. The first one is without replacement. Without replacement में how will we have the first non-face card is not replaced. Okay, तो पहला कार्ड क्या है? हमको see we have to find out no this thing. What do we have to check? They're independent or not. Independence के लिए they had given us the few definitions. What was the definition? Probability of A such that B should be equal to probability of A. So this was the condition that was given to us. This condition for independent events, right? This was the condition that was given to us. If this holds, मतलब yes, they are independent events. ये भी एक condition है for independent events, okay? But this is the main definition. This will also hold. ये भी true है. This is also true. But right now, since they are talking about condition, one card and then this is the second card, so we will use this one. Okay. So what do we have to find? We have to check A, probability of A such that B is equal to A, or else probability of B such that A which is equal to probability of B. मैं यही वाला condition statements वापस लिख रही हूँ. So ये दोनों में से कोई भी एक. Like you have to find out if that comes out to be true. मतलब yes, they are independent events, or else we will call them they are not independent events. Without replacement, as I said. So let us find out probability of now. Now again, the same question. How should I write? Should I write it A such that B, or should I write it B such that A? Okay. क्या है question में? Given that it is a non-face red card and the second card is a face card. So what is our statement? Second card is a face card given that it is a red card already. Okay. So then it will be written as probability of B such that A, because B is nothing but B is actually a face card, correct? So it is a face card given that it is a red card. So this one, A tha, it was a non-face red card, no? So this is already given, and B was what? It's only a face card. space given that it is a red card. So we written it as B such that A, which should be equal to what? If it is independent, if it is for that to be independent, probability of B such that A should be equal to B. Probability of B. Let us check if it is probability of B only. B such that A. This is what? This is without replacement as I said. So without बिना replace किए. पहला card क्या था? 52 में से whatever that card you chose. And then the second card is a face card. Okay. First card you're not replacing. So now remaining how many? They're talking only about the second card now. Okay. So just forget about the first card. Second card लेने के लिए पहले 52 था. First card you had already picked up, now gone. Remaining how many? Only 51 number of cards are now left. So 51 में से what are the chances that they are having face cards? So the face cards would be 12 in number, correct? So 12 by 51. What did I tell you to check for that whether it is equal to an independent event or not? That should be equal to probability of B. Is that equal to probability of B? No. Probability of B is 12 by 52, correct? This is equal to 12 by 51 only. This is not equal to probability of B. Hence, in this case, you should write in this case A and B are not independent. Don't write dependent. ऐसा word नहीं होता है. Independent or not independent. That is what you can write. Okay. Let us come to this question a little later. I need a little more space for the previous one. We have just finished with without replacement. We have to do it for with replacement also. Let's do it for with replacement. The second one with replacement. Now with replacement, as I said, when you pick up the first card, you're putting back again the second card, correct? So again, the same thing only you have to find out. B such that A. We have to check whether this is equal to, check if this is equal to probability of B, correct? If it is equal, then yes, it is independent or is not independent. So now we're going to check it for the second case. Second card drawn is a face card. मतलब पहला कोई तो card था और फिर अभी replacement है. मतलब they are replacing it. मतलब जो पहले 52 था उसमें से one you had picked up. Then उसको again you're putting it back. So the second chance will be the number of cards are 52 only, right? 52. And then how many total number of face cards? 12 again. So this is 12 by 52, which is same as 3 by 13. Is this equal to probability of B? Oh yes, this is equal to probability of B. 12 by 52, which is equal to 3 by 13. Yes, this is equal to probability of B. So hence, probability of B such that A, which is equal to probability of B. Hence, here, event in this case, A and B are independent. Alright? So you will write in this case A and B are independent. When the above case it is not independent. Okay, don't write it as dependent, it will be wrong. Okay, so now the one tiny question I wanted to do is that one, the above one. I think we can finish that. Let me just write the question over here. I typed it, but there's no space now. Just one second. If A and B, this is like ulta, huh? पहले वाला ऊपर वाला question में definition was given, some situation was given, and they asked you to check if it was independent or not. Now they're telling you that A and B are two independent events, okay, and probability of A is equal to 3 by 5, probability of B is equal to 2 by 3. You have to find out probability of A intersection B, probability of A intersection B dash, probability of A complement and B and intersection B. Just a second. Probability of A complement and B, probability of A complement and B complement, probability of A union B. Okay, so all the things that are given to us, let us quickly find out one by one. We'll do with the easy ones. As he said, they are independent. Okay, independent means what? The first definition, of course, with respect to this thing also holds. What was the other definition now? And these are all simple basic terms. No, what are the other definitions? Now, when these things, if A and B are independent, then A and B dash will also be independent. A dash and B dash also independent. A dash and B will also be independent. मतलब ये दोनों independent होगा, ये दोनों एक दूसरे के साथ independent होगा, ये दोनों एक दूसरे के साथ independent होगा. That is what it means. So when Yes, when A and B are independent, so we will have A dash and B dash are also independent, A dash and B is also independent, A and B dash are also independent. Likewise, you can easily find out. So we have probability of A, we can easily find out probability of A dash, right? We need A complement and B complement. That is nothing but probability of 1 minus A. That would be 1 minus 3 by 5. That's equal to 2 by 5. Probability of B complement will be 1 minus probability of B. That will be 1 minus 2 by 3. That is equal to 1 by 3. Alright. Now, what is the first one? Probability of A intersection B. A and B are independent events. So probability of A intersection B will be, according to the formula, it will be probability of A into probability of B. This is equal to probability of A. The answer is 3 by 5. B, the answer is 2 by 3. So when you multiply both, you get the answer as 2 by 5. Next one is probability of A intersection B dash. Okay, probability of A intersection B dash. They're independent, so both will get multiplied. Probability of A into probability of B dash. What is A? A was equal to 3 by 5. B dash is equal to 1 by 3. Okay, 3 by 5 into 1 by 3, that will be 1 by 5. Third one is probability of uh, A dash intersection B. A dash intersection B will again be the same. Probability of A dash into probability of B. What was A dash into B? So you just multiply this and you will get the final answer as 4 by 15. And then the next one is probability of A dash intersection B dash, which is same as probability of A dash into probability of B dash. This is same as both the values. When you multiply, you get 2 by 15. And the last one. Last one is what? Probability of A union B. Union, we can easily find out using addition theorem. We know that already. Probability of A union B will be nothing but probability of A plus probability of B minus probability of A intersection B. This will be all the answers given. A was 3 by 5 plus 2 by 3. 3 by 5 plus 2 by 3 minus how much was A intersection B? Section B was 2 by 5, right? 2 by 5. So when you kind of multiply this, everything make the denominators common, divided throughout by 15. So this is nothing but 3, 3 are 9 plus 5 to the 10 minus 9 to the 18. This becomes minus 9. 10 minus 9 to that becomes, just a second. Yes, so this is 2, 3 is 6, right? Okay, so that is 19 minus 6, that is 13 by 15. Alright, so this is the final answer. So today we have finished with the lesson probability as well. This was the 7th lesson of the textbook. I am again suggesting you go through permutation combination, make it clear, and then only you should come to this lesson. We finished with conditional probability. We started with conditional probability last time. So we have gone through a few sums on conditional probability, multiplication theorem, independent events, and a few sums examples based on all of that. Okay. We'll start with the next lesson in the next class.